Locally?
Yeah.
No.
Okay. There's only 7 of you back. I'm not sure if I should wait for some time, for maybe a minute, to wait for everyone to come back or not. Okay, I'm gonna start anyway. So I think we will have to skip this example. We can come back to it later, or maybe okay. Okay, you can all hear me, right? Before I continue, I will just want to make sure you can all hear me. Please type yes, because I'm using the headphones now. Okay, thank you. Okay, I think we can look at question 11.1. So let sigma denote your standard deviation, and let be this be your any efficient asset, and let this represent the market portfolio. Derive the equation of the capital market line. Use the sketch to illustrate your answer. So how many marks? Okay, I hadn't put how many marks. But anyway, if they ask a question like this, so basically derive the equation of the capital market line. Sorry. Okay. So not everyone is coming back. They are gone. So anyway, so again, we know that by one fund theorem, when you have a risk-free asset, it's going to be somewhere there. Okay. This is going to be your okay, so this is going to be your risky assets. So we have previously stated, like at the beginning, that your market portfolio is going to be efficient. So it's going to be efficient, and it's going to be somewhere here. It's going to be here. Again, you guys will have to like argue this, right? So this will be your market basically. So they say represent the market portfolio, derive the equation of the capital market line. So basically, to find the equation of the capital market line, you will have to say the returns of this thing of the portfolio minus risk-free rate over sigma equals to returns of the market minus risk-free rate over sigma m. So basically, this is the okay. So this is the equation, and then this one is the sketch, basically. So here they say that the slope of the capital market line K is often referred to as the price of risk. Use the equation of the capital market line to explain the statement. So I've already like okay. So I have already explained this in the first video. So I'm just gonna move to CAPM as a pricing formula. I hope okay. There are 2 questions. Oh, okay. They say yes. They just confirming they can hear me. So for CAPM, so CAPM can be used as a pricing formula, right? And remember that CAPM is gonna be what? It's gonna be your CAPM is gonna be what? CAPM is gonna be the returns of asset minus risk-free rate equals to beta I returns of the market minus risk-free rate, right? So if you wanna find the price of your asset, not necessarily the return, but you wanna find the price of the asset I, then you'll have to do the following. So can let's say that P is the price of asset I, and Q is the payoff, right? Payoff, and this payoff is a random variable, right? Nellis, is there? I saw a question. Is the Jensen index and performance evaluation not in the scope? I think they are. I will check them out and then get back to you. So okay, so the payoff Q. So okay, so if this so if this is the case, you can simplify this equation. We know that the returns or the expected return is going to be the expected payout minus the price over the price. You can basically write this thing as the expected payout minus 1. You're basically like simplifying it. From CAPM, you can basically write this thing like the return, instead of writing the return, this thing, instead of writing this, you can write this. So you can write payout over P minus 1 equals to risk-free rate beta I Rm minus Rf. And you can take this one to the, again, I'm like to the other side. So basically, you will have 1 plus. So you are trying to make P your subject of the equation. So you will have P equals to Q over 1 plus Rf plus beta I Rm Rf, right? So if they ask you to use CAPM, it has a pricing formula. So this is how you're gonna price your asset. So you're gonna look at your payoff over, and also all the other values you have used in the last things. So anyway, so yes, basically, from here on, you also have to know that it is not always the case where you can actually find your beta, where your beta can be given, or maybe if your covariance of your market and the asset is also given. So if they are not given, but you are told about the payoff, you can take it a little bit step further, right? You know that beta is going to be the covariance of I m variance of the market, right? So this thing is the covariance of what? Is the covariance of Ri and the market, right? So how do you find the covariance of the market and Ri, right? So I am trying to like simplify this. So what can you do here? So Ri, right? You already know what Ri is. Ri is going to be your payout. Is going to be your payout minus price over P. So you can basically just write it again as Q1. I mean, like as Q over P minus 1. So okay, so basically you're gonna have a 1 over P. Sorry, 1 over P covariance of Q and the market. So And then you can take this thing back to the equation. So you know that BP gonna be equals to the P out Q 1 plus RF RF what? RF plus, so beta is gonna be 1 over P 1 over P what? So you have covariance of Q and RM over market risk times the return of the market minus the return of risk-free rate. So when you simplify this, you can take this thing to the other side. You can multiply it this side. And then when you multiply it, so you will have P equals to 1 plus RF plus covariance Q. I'm like the variance of the market, again, I'm like the variance of the market over the return of the market times the risk-free rate equals to Q. So you can basically write your P, your price, as what? So you can just say expected payoff plus covariance of Q. Q squared M over 1 plus RF. So basically, I'm not sure if this makes sense, or you can actually write it much simpler. Like it looks better this way, like we have done in the book. So Q, and then you're going to say 1 over 1 plus RF. So this is how you can write your prices. So this concept of certainty equivalence, you're mostly going to use it to look if whether there is an arbitrage opportunity or not, right? You're mostly going to use this to see if there is an arbitrage opportunity or not. So basically, this formula will tell you that. So if you have payouts, so if your prices of okay, so let's say maybe you have two assets. Let's say maybe you have asset 1 and asset 2, right? And asset 1 has price of P1, and then this one has price of P2, and this one has Q, can pay out of Q1 and pay out of Q2, right? So to find the price of the combination of these two assets, right? So let's just say maybe you combine them two together. So the price of these two assets, 1 and 2, basically again. So you're gonna put back that in that equation 1 plus RF. So the payouts, right? So they're gonna pay out in Q1 and Q2. So these things are both expected. So minus the thing over there. So minus the covariance Q1 and Q2 RM over market risk. Market return minus risk rate. So when you simplify this further, okay, you're gonna find that you have the prices of P and the prices of P2, right? So basically, prices. So when your payout again increases, so should your price. So if your payout increases by double, we also expect your prices to also increase by double. So basically, they should not be a bulk discount. So there should not be any bulk discount. So this is okay. So, and if this is not the case, if the price of 1 and 2 is not equals to the price of P1 plus P2, then there is arbitrage. There is an arbitrage opportunity. And can you guys hear me though? I want to check if there's any questions. So there's no any questions at the moment. So are you guys satisfied? Any questions? Okay, I'm gonna check the question again. It says that Jensen index and performance evaluation. Okay, I will check them later. Okay, I am guessing everyone else is good. So anyway, I'm gonna move from this one. I'm gonna go to factors. Right. So you can send me questions if you feel like you wanna ask questions later on. You can still send me questions, and then I will I can go to do them, and then I can send them to you. The other thing that I'm gonna make a summary. So I am done with chapter 6. I just have to make a summary for chapter 7, and then chapter 8 as well. So for chapter 7, I already wrote it down. So I just have to type it down. So basically, I will give you your summary for these things that we have done later on. And these sessions, I'm gonna record them and then put them somewhere, I think on YouTube, because I can't send them to you one by one. So anyway, so we can move on to factor models. Is that fine with everyone? Oh, by the way, my walls are very thin. So if you hear sounds, it's on the hallway. So anyway, I will assume you are all fine. So I think maybe we can start with factor models now. So anyway, for factor models, it's much simpler. In the questions, I can show you how to answer these questions. So basically for factor models, so this one, it's a pricing models where you wanna use factors to like estimate your returns of an asset. So I am not gonna go into details about what are those kind of specific fundamentals and macroeconomics and statistical factors, but you can like learn them on your own because they just have to like state them. So anyway, so the first factor, again, so the first one we can do is single factor because it's much simpler. So here we will look at how the returns of an asset are affected by they so they are affected by one vector. So there are no multiple factors affecting our asset. So basically, so to find this return, so you can try it like this. So you can see that the returns of asset I is going to be equals to AI. Okay, so anyway, this is your error. Again, you can sometimes call it a random noise, and this one is going to be called your factor loading. And this one is going to be called your intercept. So so there is not much happening in this chapter. Again, the question they love to ask mostly, they are in terms of like finding, so they are in terms of proofs, or they normally ask for those lab chapters, like this last sector where they ask about ABT. But anyway, this is how you represent your vector model, right? So if they ask you to calculate your returns based on a vector, you will have to find your intercept, your your factor loading as well as your error. If not, you will have to like estimate it and then find your expected return. If this is the case, so this is what you will have. Again, there are other assumptions that you need to know. So the assumption is that the expectation of the error is going to be 0. The variance, or the covariance, actually, the covariance of error and market is going to be 0, and the covariance of error I and error J is going to also be equals to 0, where I is not going to be equals to J. Sorry, I resist. So. Sorry. So anyway, so of I based on factors. So basically, if you don't have the state of your returns, you can still use factor models. So you can still look at a factor to find your variance of a model, right? So this basically the so this is gonna be the variance of I and I, right? Okay, so do you guys want me to like prove it, or should I just write it down?
Isn't it basically the same as the previous one you did?
Yeah, basically.
So it's fine.
And this one has a factor. So you don't use the market premium, you use any factor. So this factor can be the market premium, or it can be any factor, unemployment, GDP, or whatever. But then you can just use any factor to calculate the variance of return. So anyway, yeah. And you can also find variance. So let's just say covariance, actually, covariance of return of I. And also the returns of f. So you can use the same method. So here basically you're going to have factor loading squared times vector f plus the variance of your error, and then here you're going to have bi and bj sigma squared f where, so this is where your I is not equals to j, right? Because if your I is equals to j, then you'll have to include this. So anyway, so now we're going to move on to building a portfolio using again, so basically using a vector. So this idea also work for like two vectors as well, like two vectors or multiple vectors. So to find a portfolio, so we know that to find the returns of a portfolio, you have to sum the weight of I and the returns of I, right? So you will end up with something like this. You will have the weight of I, AI, plus the sum of weight of I, vector loading of I, times the vector. Let's say this is expected. Maybe I should not look at it is expected for now. So that we can include the error plus the sum of the weight times the error, right? So this is how you find it. So you can just like simplify this and say that BF plus error. So to find the returns again, you're going to use the same thing to find the risk of a portfolio. Again, you're going to use the same again, you're going to use the same style. So for multiple factor, now in our course, normally when they talk about multiple factor, they just talk about okay, let's say you have returns, you have of I, so you're going to have your again the intercept plus factor loading for factor 1 plus factor loading for factor 2. Normally, so this is what they normally write. So actually you can write it, so you can have like extra, so you can have like 3, so you can have like B3 IF3, so you can have as many as you want, but then when you look on other books or on other articles about factor, so about multiple factor, they use this, they say A plus B B1 I F1 plus again before they put factor 1, they would actually use beta. They would say beta I, and then they would have any other factor, beta 1 I F1 plus other ones plus the error. So this is what they use in other, again, so in the other books. Although in this course we normally look at a factor again, so we normally would look at CAPM as a single factor. In some books, they use it on multiple factor. So we can try to understand more about CAPM as a factor model, but there is not much. So it just makes sense to write it like this. But then when you do a test, this is how they would normally give you your thing. And you can see for CAPM, if we were looking at this equation over here, you can see that our factor is the market premium. Is your market premium, basically. So the same thing can apply on how to find your returns. To say the returns of I and the risk of I. So you just follow the same procedure. So do you guys want me to do this proof for finding the mean and the variance? Okay. I am assuming you are all fine with this one. So anyway, so now we can move on to ABT. Hi, I'm fine with the proof. We can move on. Okay, thank you. So for ABT, for your arbitrage pricing model, so now, sorry, I forgot where I put my proof actually. So anyway, for your, again, so just like we did back then, we are trying to, okay, so, okay, let's say maybe you have two assets. So you have asset A1. Okay, yeah, I'm gonna say 1. So you're gonna have A1 plus B1 F. And then we're gonna, okay, let's say maybe we have another one. Okay, let's say maybe we use I and J, because I think that's what they used. And the returns of J, you are gonna have A, J plus B, J, F. So for your, again, okay, we can try to understand our idea of arbitrage again. So firstly, when we spoke about arbitrage, we say that we are looking at when the things, again, I mean, like when again, so when you have same price, same discount, or same characteristics, but then you have different prices, or you have the same price, same risk profile, but different output. And then in last chapter, we look at arbitrage as a, again, so he's trying to say that there is no bulk discount. So now we will try to learn like what is an arbitrage in terms of like your, okay, so in terms, so what will be arbitrage in terms of your factor models, right? So we will assume that I and j are not the same. And we will also assume that your bi, this is bi is not the same as bj. So basically this means that these two things are not the same. Anyway, to build a portfolio, you can build a portfolio on this. So you can build a portfolio. So do you guys want me to do this proof anyway before I can start? So to build a portfolio, you can say that okay, let's just say that this one's going to be the weight of I. So to find the returns of your portfolio, so you are basically going to have alpha returns of I plus 1 minus alpha, the returns of j. And then you can basically simplify this. You know that you can have AI plus BI F plus 1 minus alpha AJ plus BJ. Yes, okay. And then we're gonna try to put, okay. We will try to put these factors together so that anything which has a factor, we just put it together anyway. So we will have something like this. So we will have we can just say alpha AI plus 1 minus alpha AJ plus alpha BI